Hello, everybody. Tom Dennis has graciously agreed to bring all of us, including me, up to state on wave energy in a very short period of time. So, welcome. What's the state of wave energy today?
Yeah, thanks, David, for wanting to get the message across to people. Firstly, the state of wave energy, it's been around for a long while. It has been difficult in many cases for various reasons to develop, but right at the moment it's on the cusp of commercialization. So there are two sort of different types of technology, the nearshore ones and those that are offshore in much deeper water. And they're they're a little different to what I've been used to, where my experience lies in the field, which is in the more nearshore or onshore type technologies, and they're very much at that commercialization phase, having been proved through demonstration projects.
All right, cool. And are you familiar with what capacity factor is for a wind generator?
Yeah, absolutely.
So, what's the capacity factor for your average wave generator out?
The capacity factor, and it's important to understand the difference here. Capacity factor versus how often they're operating are actually different things. The capacity factor is roughly the same as that of wind turbines at around the 35, possibly 40%, which means that it's on average it produces 35 to 40% of what its maximum ability is. Now, there are also what a lot of people are concerned about is how often is wave energy working compared to, say, wind energy. In other words, how much does wind energy vary versus wave energy? Well, wave energy is much more consistent. In other words, it doesn't vary as much over a period of time than wind does. Solar's the most variable of all. We all know that solar does not operate at all, does not produce power during the night, and very little during heavily clouded days. Wind energy is better, but wave energy is even more consistent again. You can have wave energy producing energy much of the time, particularly in the regions that have the most consistent waves.
Yeah, because in Hawaii, I grew up there, and you had pretty constant waves, but you had times where it was just flat and there was nothing going on.
Yeah, that's very much a seasonal thing in Hawaii. Um, the winter swells are very regular, but the summer times can be really quite flat. Not that there's that much difference between summer and winter in Hawaii, of course.
But the surfing's quite a bit different between
Yeah,
the
the
two.
surf is very different between winter and summer.
So, on average, what's the cost for, like, say, a 1 gigawatt set of wave generators?
It's an interesting question because it can only be estimated at this time because, of course, there hasn't been a gigawatt of wave energy produced. We've had some studies done independently by the Australia's National Science Agency for our particular technology, and the prediction there for 1 gigawatt of power is that it would be just a little over $1 billion US for a gigawatt. Now that's less than, for example, a new coal-fired power station would be today, less than nuclear power, and very comparable to the other renewables as well.
Yeah, you're right in line with what onshore wind is.
Yeah, exactly. So whilst it's not there right at the moment, it has that's a very authoritative study that made that a prediction as to what the cost will be as more and more of the capacity is installed. That's one of well, people think that costs come down over time. Well, they do, but it's more directly it's to do with the amount of installed capacity. And as you install more, you get economies of scale, but you also get what's called learning by doing, and
Yeah.
that's
Oh,
what
yeah,
drives.
that's gigantic.
Yeah, it is and that's where solar and wind, of course, too, but solar particularly has benefited greatly over recent decades. The cost of solar power only a few decades ago was 100 times more than it is now, and that's primarily through learning by doing. And there were so many skeptics back in those days that people would say, no, solar will never ever be comparable, or be able to compete with coal and nuclear and so on. And now they're just blowing them out of the water in terms of production costs. So we would expect something very similar to happen with wave energy. So the difficulty is that with any new technology, they need some level of support, because there's what's called the valley of death. You have a technology that may be proved and you can see where it's heading, but it's not there yet. And so getting installed capacity in requires, well, to drive down the cost, you need to install projects, or you need to develop projects. But to develop projects, the cost has to be, in
Right.
many cases, already down, because people don't pay for energy that's more expensive than other energy. So how do you get it down? It's a bit of a catch-22 chicken and egg issue, but that's where some level of support comes in handy, and certainly all forms of energy in the past have had that support, which is what's allowed them to decrease their costs.
Well, and I mean, even to this day, hydrocarbons have support. So,
Yeah, that exactly, and they did have more, even more in the early days. Nuclear was strongly supported in the early days. Just wind and solar have had that support too, through tax credits and that sort of thing in more recent times. Um, there's another major benefit though to wave energy that a lot of people don't understand, and that is its ability to fill in the gaps. Energy generation when wind and solar aren't operating. And there's been numerous studies on this, including one that involving our particular technology, but there's been others as well in through Europe and so on. And what it strongly has found is that wave energy, because it's essentially uncorrelated with wind and solar, it means that it's the gaps in generation of wind and solar. Wind and solar together help each other to some degree. If you only had one, you would have much larger gaps in generation. But when you combine them, they help to some degree to fill in those gaps. But when you add wave energy again, the result is quite phenomenal. Wave energy fills in the gaps when wind and solar aren't operating to such an effect that the estimates have been that the cost of an entirely renewable grid operating with battery storage, you can reduce those need for the batteries so much, and the batteries are the expensive part.
yeah.
You can reduce that cost so much that the overall benefit to the grid by incorporating wave energy in with wind and solar can be as much as 3 times lower and a third of the cost, because you do
Now
away with.
is wind working better with that due to actual climate things of, I'm sorry, wave, that you get more waves in the evening or you get more waves during times of year when the wind is down? Or is this just the fact that you have three random setups that are each at about 33% and they just statistically, a lot of the time, they will hit weak
Well,
spots of
that
the others?
consistency issue that I mentioned at the beginning, that's an important factor for that makes wave energy so important to have in that mix, in the mix of the three. It's solar and wind both have what's called diurnal aspects. Solar particularly. Diurnal basically just means, it depends on the time of the day. So solar very much depends on the time of day, but wind does to a large degree too. The wind tends to die down at certain times of the day, and particularly if you're on the coast, you'll get sea breezes that pop up, later in the day and that sort of thing. Wave energy has no diurnal aspect at all. The energy in waves, the type that people try to extract from swell waves, not local wind waves. Now, swell waves are generated perhaps thousands of miles away and from large storms out in the major ocean basins, and then they propagate towards the coasts. So there's no real correlation between the local wind and the type of waves that produce the energy that we're after. Yeah, that lack of correlation and the additional consistency of waves really leads to an amazing effect on the way that it can fill in the gaps and get an almost consistent purely renewable source from those three types of renewable generation with much, much lower requirement for battery storage.
All right, so is there a commercial installation everywhere, or is everything still test installations?
It's at the moment that, as I mentioned, wave energy is on the cusp of commercialization. So there should be some commercial operations soon, but I'm not au fait with every technology out there and what they're doing. But yeah, certainly with our own, and I believe with several others out in the deeper ocean, there's projects that look like being commercial in the relatively near future, in the next year or two.
Okay, I was going to say, define the word soon. So the next year or two?
Yeah, I would think so.
Yeah, 50 years ago when I started in physics at the university, it was, we'll have fusion power in 20 years.
Yes,
And
yes.
they were accurate because we are still going to have fusion power in about 20 years.
Yeah, it's like a sort of time lock, isn't it? It's
Yeah.
just constantly in that time frame.
Yeah, but a year to 2 years, that's real. All right. Well, thank you very much. Do you have anything else to add to all of this?
No, that's about it. Other than to say, yes, watch the space, and I do think that you'll be seeing some real progress with wave energy in the coming few years.
Well, fantastic. That'll make you happy, and it will make my mom happy.
Yeah, it certainly will.